Hi all, in this video we'll be looking at a special case. In the previous video we're looking at just moving these graphs around to the right and left by changing the C value. Now in this case we're going to continue changing that C value, but we're going to look at a special case in where the sinusoid of sine and cosine can be equal. Now in our last video we started setting up this play feature here where we're just shifting this graph to the left and right. You can do so if you watch the last video and see how I set it up. Now, what we're going to do is see where sine of x is equal to cosine of x and see if we can nut out an equation which they are equal to each other. So if I type in cosine here, bring it to 0, we can see that these aren't the same, right? But they're the same shape and they look like if you move this across enough, you will actually make the same graph. So let's see what happens. Let's press play now. What just happened there? Well, we can see that this graph in blue is definitely cosine and this graph in red is definitely sine, yet they're complete overlap. Therefore, we've seemed to have stumbled on something here in which sine of x must be equal to cosine x takes c, where c is equal to 90 degrees. So what we've found here is actually an important rule in trigonometry, and I'm going to write this down on my OneNote page over here. So we've found that sine of x, and I might make that a bit thicker like that, we found that sine of x is equal to cosine x take 90 degrees. Okay, now we're happy with that. So we've got that from our graph. Can you think of another way of determining that this equals this? Well, what about this? Does this ring a bell? Does it look like something else that we've looked at before? Well, it's a trig identity, right? This is a difference law. Cosine A take B, yada yada. So let's see if we run. So we can see if we can run this through our cosine for a difference rule, then we should be able to, a sine of x should pop out. So let's go through this. So we're looking at cosine A take B, which is our difference rule for cosine, which goes cos AB, and then plus is always the opposite, and then we go sine. Now we're trying to evaluate it for x take 90 degrees, right? So let's just sub in these values. So cos x, cos 90 degrees, plus sine of x, sine 90 degrees. Let's evaluate. Cosine x stays the same, times by cosine 90, which we know is 0. We can see that on our graph over there as well, it's 0. Plus sine of x times by sine 90, which is 1, right? So the cosine x times 0 goes to 0, and then sine of x times 1 is just sine of x. So we've just shown it using our trig identity. Now this is just one of our special cases, and it's an interesting thing to note that we have that relationship.